Welcome back to our channel. We are the Lab Group 21, and for today's video, we will be showing you how we perform the third lab experiment with the title Fixed Resistor. Enjoy watching! The objective of this experiment is to determine the value of the resistance of a fixed resistor using the color coding technique, and the materials used for this experiment are 5 pieces of fixed resistor.
Procedure. For the last laboratory experiment this quarter, we were tasked to do the laboratory experiment 3, fixed resistor. First, we prepared 5 different images of a 4-band resistor from the internet. The first resistor had brown, black, brown, and gold color bands. The second resistor had brown, blue, red, and gold color bands. The third resistor had brown, black, orange, and gold color bands. The fourth resistor had yellow, violet, brown, and silver color bands. The fifth and the final resistor had a yellow, violet, green color bands, and has one no color band. Second procedure, we determined the value of each color band based on our resistor chart provided. Third, we determined the value of the fixed resistor in ohms by using the computations that was presented in the demo video of Sir Ferds Monoso. Fourth, we filled out the table and recorded the value of the 5 fixed resistor. Lastly, we answered the discussions, observations, analysis, and conclusions.
Let's move on to the tables. In the first column, we have the resistor and its corresponding number. The second column below the color bands, we have the first band, which is the first digit. Next to it is the second band, which is the second digit. Next is the third band, which is the decimal multiplier. Next is the fourth band, which is the tolerance. And in the last column, we have the value of the fixed resistor in ohm. Resistor 1, first band brown, second band black, third band brown, fourth band gold, with the value of the fixed resistor within 20 ohms to 105 ohms. Resistor 2, first band brown, second band blue, third band red, fourth band gold, with the value of the fixed resistor within 1.52 kilo ohms to 1.68 kilo ohms. Resistor 3, first band brown, second band black, third band orange, fourth band silver, with the value of the fixed resistor within 9 kilo ohms to 11 kilo ohms. Resistor 4, first band yellow, second band violet, third band brown, fourth band silver, with the value of the fixed resistor within 423 ohms to 517 ohms. Resistor 5, first band yellow, second band violet, third band green, fourth band none, with the value of the fixed resistor within 3.76 mega ohms to 5.64 mega ohms.
For the computations, resistor 1 in the first band brown has the value of 1, in the second band black has the value of 0, in the third band brown has the multiplier is the value of 10. Thus 10 times 10 is equals to 100 ohms with plus minus 5% tolerance. To compute for the range, we multiply 100 ohms with 5% or 0.05, which gives us a product of 5 ohms. Furthermore, we subtracted 100 ohms from 5 ohms, which is equals to 95 ohms, and added 100 ohms to 5 ohms, which is equals to 105 ohms. The value of fixed resistor is within 95 ohms to 105 ohms. For the resistor 2, first band brown has the value of 1, second band blue has the value of 6, and the third band red as the multiplier has the value of 100. Thus, 60 times 100 is equals to 1600 ohms, which we converted to 1.60 kilo ohms with a plus minus 5% tolerance. For the range, we multiply 1.60 kilo ohms to 0.05, which we arrive with a result of 0.08 ohms. We subtracted 1.60 kilo ohms to 0.08 ohms, which is equals to 1.52 kilo ohms, and added 1.60 kilo ohms to 0.08 ohms, which is equals to 1.68 kilo ohms. The value of fixed resistor is within 1.52 kilo ohms to 1.68 kilo ohms. Resistor 3, first band brown value is 1, second band black value is 0, and the third band orange as the multiplier has the value of 1000. 10 times 1000 is equals to 10,000 ohms, which we converted to 10 kilo ohms with plus minus 10% tolerance. Range is equals to 1 kilo ohms. The value of fixed resistor is within 9 kilo ohms to 11 kilo ohms. Resistor 4, first band yellow value is 4, second band violet value is 7, and third band brown as the multiplier has the value of 10. 47 times 10 is equals to 470 ohms with plus minus 10 tolerance. Range is equals to 47 ohms. The value of fixed resistor is within 423 ohms to 517 ohms. Resistor 5, first band yellow value is 4, second band violet value is 7, and the third band is the multiplier, green has the value of 100,000. 47 times 100,000 is equals to 4,700,000, which we converted to 4.7 mega ohms with a plus minus 20% tolerance. Range is equals to 0.94 mega ohms, and the value of the fixed resistor is within 3.76 mega ohms to 5.64 mega ohms.
The resistance of a material is the ratio of potential drop across the material to the current flowing through it. Most manufacturers identify the resistance value of a fixed resistor by the means of a color code. There are different values of resistors available from 1 ohm to millions of ohms. It is impossible to have each and every value of resistance like 1 ohm, 2 ohms, 3 ohms, 4 ohms, and etc. But rather, they are in tens, hundreds, thousands, or 1 million. To prevail this, resistor color coding technique was introduced. The number of color bands can be from 3 to 6, and these color bands on the resistors denote the value of resistance, tolerance, and sometimes temperature coefficient. In the laboratory experiment, we used 5 different 4 color bands, which means band A is the first digit, band B is the second digit, band C is the multiplier, and band D is the tolerance. Tolerance is the percentage of error, and it is how much we can expect resistor's actual measurement. For instance, if the band D is gold colored, then the tolerance is 5%. It means you can expect 5% change in the value of resistance. To read the color bands on the resistor, we need to follow the color code chart provided.
After the laboratory experiment, we observed that the different colors correspond to different values in the resistor chart provided. Also, we have observed that by multiplying the value of the first and second bond to the third bond as a decimal multiplier, we can get the value of the resistance or resistance level. And to calculate the range, first, we must multiply the value of resistance to the tolerance level of the fourth bond. And the product will then be subtracted and added. Therefore, the actual value of fixed resistor can be within the range.
We further analyze the table in contrast to all resistors. Resistors 1 to 5 differ in the value of the fixed resistor. Since all bands attached to each resistor have distinctive colors, thus with different colors will be different values, decimal multipliers and tolerance. Also, we notice that the higher the value of the decimal multiplier or third band, the higher the resistance level. Additionally, the higher the tolerance, the larger the difference in the range of the resistance. Like in resistor number 5, the tolerance is plus minus 20%, and the lower the tolerance, the smaller the difference in the range of the resistance. Like in resistor number 1 and number 2, the tolerance is plus minus 5%.
This laboratory experiment sought to determine the value of resistance of a fixed resistor through the use of the color coding technique. After the trial, the results showed that the objective of the experiment has been met. Based on the details given in this experiment, we can conclude that the value of the fixed resistor is determined by the varying colors of each band and its equal value. Also, in the computations, the higher the value of the decimal multiplier, the resistance will be in higher value. And the tolerance is directly proportional to the difference in resistance range. In addition, we conclude that the color coding technique is a great tool in identifying the value of the fixed resistor. However, if an individual wants to know the actual resistance of a material, a device called multimeter or ammeter will be used to get the exact measurement of resistance in the resistor.